All right, 2.3, product and quotient rules. Super important. Again, we'll use these all year. In fact, this whole unit is stuff that we'll use all year. So if you don't get it now, the issue is gonna compound as we go on. I guess that's truer in math than most other courses. Like if you miss a unit of history, well, whatever, then you got a little gap, but it doesn't mean much later on. Here, we're using power rule, quotient rule, chain rule. We're going to use all that stuff all year long. So just trying to emphasize the importance of these early lessons to build the foundation so that when we apply it, you're not stuck trying to figure out a product rule when that was, 2 months ago. All right, product rule. First thing I'm going to show you is what it's not. So I'm going to write this down and I'm going to put a big X through it. And so if you think it would be even more confusing to write it down, then don't even write this down because I'm going to write the wrong thing first. So it would be nice if the derivative of a product, remember product means multiplication, we're multiplying. I'm taking the derivative of this product of functions. It would be really, really nice if I could just take the derivative of the two pieces and multiply them back together. Like that's how we'd think it would work. It'd be nice if it worked that way. Limits work that way, but derivatives don't work that way. So you can't do that. There has to be this special rule to use to handle when we're finding the derivative of a product. Because you can't just find the derivative of the pieces and stick them back together. It'd be nice, and some of you will try that, but that's not right. All right. Now, if you didn't write that down, you do need to write this down because this is the real product rule. Derivative of f times g is f of x times g prime of x plus the other way around. G of x, don't write that, I gotta erase that. Get rid of that, don't see that, that's not there. G of x times f prime of x. How most people remember it is it's the first times the derivative of the second plus the second times the derivative of the first. So there it is in like official calculus format. But how most people just remember it is and the order doesn't matter since you're adding. So if you get the order backwards, it doesn't matter. It's one of them times the derivative of the other plus the other way around. So product rule is usually not a big deal. The main thing is don't just take the derivative of each piece and multiply them together. Derivative of one times the other plus the other times the derivative of the other one. Let's do some examples of this. Let's say y equals 4x minus 2x squared times 3x minus 5. So I guess first thing we notice is this is a product rule question because we're trying to find the derivative of a product. And it would be nice if I could just say, oh, it's the derivative of this one times the derivative of that one. But it doesn't work that way. You've got to use the product rule. And initially, it's really helpful to label them. F and G. Some of you will get past this labeling eventually. Some of you will never get past this. And it's completely okay because it really helps keep things straight. And then out to the side, I'm going to write down what f prime and g prime are. Rather than try to do everything on the fly. I don't want to do that yet. So he's f, he's g. So f prime then, using the shortcut rule from yesterday, the power rule, that would be 4 minus 4x Okay with that? What about the derivative of g? What's that going to be? Just 3. Good. So now I got all the pieces to use the product rule. I've got f, g, f prime, g prime. Now it's a matter of just putting them together the right way. So y prime is the first times the derivative of the second. So the first, 4x minus 2x squared, times the derivative of the second, so times 3, plus the other way around. The second, 3x minus 5, times the derivative of the first, 4 minus 4x. And on a free response question, that would be a perfectly acceptable answer. Like, we did the calculus, the rest is algebra, we're good. On a multiple choice question, or if you're looking in the back of the book, they would do all the algebra. So let's do the algebra real quick here. Oh, a little bit of foiling, that's okay. 12x minus 12x squared minus 20 plus 20x. Again, this is all algebra cleanup at this point. Looking for like terms. Negative 18x squared. 12x and 12x and 20x would be 24 plus 20 is 44x. And then the only thing left is the minus 20. So that would be the multiple choice answer, or the back of the book answer. Probably the calc chat answer as well. So kind of depending on where the problem shows up determines which form of the answer we want. And again, one straightforward like that would probably be a multiple choice question, and that would kind of force you into some algebra. By the way, there is a way to avoid, on some problems, you can avoid the product rule. So on this one, we could have avoided the product rule by foiling first. Right? If we FOIL that out, we just have an ugly polynomial, but polynomials are really easy to take the derivative of. So it's kind of just a matter of, well, which would you rather do? Would you rather FOIL this and then have an easy derivative, or do you want easy derivatives and then have to clean it up later? It's up to you. Now, some we can force you into foiling, or not foiling, excuse me, we can force you into the product rule with things like this. Y equals x cubed times sine of x. So again, let's make the first piece of the function f and the second piece g. And then out to the side, we'll find f prime and g prime. And we'll put some people on the spot here. So John, if f is x cubed, what's f prime? Very nice. Lauren, if g is sine of x, what's g prime?
Sine of x.
Good. So now it's just putting the pieces together the right way. I am going to show a new way to write a derivative, because sometimes you'll see it written this way. dy dx, dy over dx. D meaning like differential, so change. So change in y over change in x. I like writing it this way sometimes because it's a reminder that derivative is a slope. Because change in y over change in x, that's slope. But dy dx is a derivative. But slope and derivative are the same thing. So dy dx is another way to write y prime, or the derivative of y. All right, back to the product rule. So first times the derivative of the second. So first is x cubed. Derivative of the second is cosine x. Plus the other way around. So the second times the derivative of the first. Although that's going to look funny with 3x squared at the end, so I'm going to squeeze it in there at the beginning because I think it looks a little bit nicer. That's a perfectly acceptable right answer. If you go to multiple choice or Calc Chat or the back of the book, they're going to do something that's really unnecessary. But on a multiple choice test, I think you'd recognize it, so I don't think it'd be a problem. They'd factor out an x squared. Again, does that make the problem better, worse, cleaner? Not really, but that's what they would do. So again, be careful. From your first answer to the back of the book answer, there may be some algebra involved. Hopefully it's easy enough that you can see it right away and you can just box your answer and be like, that's the same thing. F of x equals, this one's going to get kind of ugly, more for the algebra than the calculus. X minus 2 to the 5th times x plus 1 to the 7th. Nobody wants to do that. That's terrible looking. Well, you could avoid the product rule here if you really, really wanted to, right? You'd have to multiply all this out and all this out and then multiply them together. And so you'd have an x to the 12th term in there. We're not going to do that on this one. This is why the product rule was discovered, to avoid it for this kind of thing. So F and G. Again, at some point, for simpler ones, many of you are going to stop labeling them F and G and writing them separately. You're just going to have in your brain first times the derivative of the second plus second times the derivative of the first and kind of do everything on the fly, and that's okay. I just wouldn't recommend that just yet. Like, wait until you get the hang of this, and then if you start thinking, I don't really need to write all this stuff out, then go for it, but be careful. All right, F prime. All right, these are a little bit different, but I've got something to the 5th, so the power rule is still applying here. So I'm going to change this to, or I'm going to use the power rule. So something to the 5th, power rule still applies. So 5 times the something to the 4th. So it's a little bit different, but it's still the power rule. McKenna, can you use that same power rule principle and tell me the derivative of G?
Can you explain it again?
So you take the exponent comes down front, and then you decrease the power by 1. That's the power rule.
So it would be 7 and x plus 1 to the 6.
Yep.
Thank you.
Power comes down front, decrease the power by 1. Now we're all set up to do product rule. So first times the derivative of the second. I'm going to be fancy and put the 7 out front, just because it would look weird in the middle or at the end. But that's still first times the derivative of the second. I've just kind of rearranged the pieces to make it look nicer. Plus, the other way around, the second times the derivative of the first. And again, it's multiplication, so the order doesn't matter. I'm going to put the 5 in front. X plus 1 to the 7th. X minus 2 to the 4th. And once again, you're done with calculus. That's a safe stop. That's a free response answer. We're good. The reason I want to work this problem is the back of the book looks way different than that, and students are always like, how in the world did they get that answer? Well, here's how. By factoring. So both terms have some x plus 1s in it. So let's take out as many x plus 1s as we can. So, by the way, calculus is over. Now we're doing algebra. How many x plus 1s can I take? 6. That guy has 6. That guy has 7. So I'm limited. I can only take 6 of them. So I'm going to take out x plus 1 to the 6th. All right, how many x minus 2's can I take?
4.
4. This guy's got 5, that guy's got 4. So the most I can take is 4. And now I got to figure out what's left after we've taken all this stuff from these guys. So I took all of this first set of terms, I took all of his x plus 1's, they're gone. 7's still there. And I took all but 1 of his x minus 2's. On the second set, I didn't take the 5. The x plus 1's, I took 6 of them, so there's 1 left. The x minus 2's, I took all of them, they're gone. And so if I do a little cleanup work on the inside, 7x minus 2 plus 5x plus 5, I get 12x minus 9. And I have all this junk out front that I factored out. So that's kind of ugly, but that'll be the multiple choice answer on a test, or the book answer if you're checking Calc Chat or the back of the book. So many times you can look in the back of the book and instantly see how your answer is the same and you can be good. But if you look at these two answers, you can understand why people are like, wait a minute, okay, I get the x plus 1 and the x minus 2, but where does 12x minus 9 come from? Where does 7 and the 5 go? So there's a lot of algebra in there. Again, that's a safe stop, but on the test, if it's a multiple choice question, we're going to have you do the algebra. I feel like most of our lessons are 1/3 calculus and 2/3 algebra. All right, quotient rule. Quotient rule. Oh yeah, we're good on that. Well, again, how you would like it to work is not how it works. I'm not going to write the wrong one this time, but it's not. If I want to take the derivative, let's back up, of f of x over g of x, it would be really, really nice if it was f prime over g prime. And you can bet that that'll be one of the wrong answers on a multiple choice test, but that's not right. Please don't do that. You've got to learn this quotient rule, and this one's a little bit ugly. So g of x times f prime of x. So that's a little bit like the power or the product rule, because it's one of them times the derivative of the other, but it's minus, so order is going to matter here. In product rule, it was adding, so if you got the order backwards, who cares? It's just one of them times the derivative of the other, switch it around, fine. Order matters in subtraction, so you've got to get g f prime first minus f of x g prime of x all over g of x squared. You're going to use those two rules all year long, so those are highlight, note card, bathroom mirror, starred, whatever your preferred method of, hey, I need to know this, do it for that quotient rule. All right, the major mistake or the major error in the quotient rule, other than people not doing the quotient rule at all, like just doing f prime over g prime, but if they remember to try it, they have a hard time, people remember or have a hard time remembering which one goes first, because they know it's kind of like the product rule, that it's one times the derivative of the other, but what do I do with those? Subtract them. Here's how I always remember which one goes first, and I'm probably going to get in trouble because it's going to be on YouTube later, but if you're in a relationship, you're like, whoa, we shifted the relationship advice here? If you're in a relationship, the only way to make this work is, I'm talking to the guys here more than the girls, but the only way to make it work is that the GF has to come first. Right? It's the only way to make it work, guys. Sorry. In a relationship or in the quotient rule. So, silly, sexist, maybe, borderline, whatever. If it helps you remember the quotient rule, then go with it. GF has got to come first. So GF prime minus FG prime. Some people, when they're writing it down on their test, they leave out all the X's because that kind of clutters things up. GF prime minus FG prime all over G squared. So again, keep the GF first. Everything will work out. All right, let's try one. Y equals 5x plus 2 over x squared minus 1. Many of you are going to start shortcutting the product rule and not labeling things. Even I will label the quotient rule every time, even if it's just me working a quick key to check an answer. There's too much going on to try to just keep it all in my brain. So I'm always going to label. The top is F, the bottom's G, and then out to the side I'll write F prime and G prime. Let's pick on some more people here. Aldrich, how about the derivative of F? So if F is 5x plus 2, what's F prime?
5.
Good. Just 5. Angie, how about G prime? If G is x squared minus 1?
Would it just be 2x?
Good, 2x. You guys are power rule masters already. Okay, so Y prime. And again, this is where it's nice to have it all labeled out because there's so many pieces. If you try to do it in your head, you're going to mess something up. So GF prime, so G x squared minus 1 times F prime is 5. I'm going to put the 5 in front. Again, order doesn't matter when you're multiplying. So that's GF prime minus the other way, FG prime. So that would be 2x times 5x plus 2 all over G squared. And again, for your response, you're good. There's some algebra cleanup to do, but if it's a free response question, leave the algebra alone. If it's a multiple choice question, well, let's do a little cleanup work to just remind ourselves how to do algebra here. Distribute the 5, distribute the negative 2x, so be careful with the minus signs. So minus 10x squared minus 4x. And I'm not going to FOIL the bottom. I'm just going to leave that alone, but I can clean up the top a little bit. Negative 5x squared minus 4x minus 5 all over x squared minus 1 squared. So there's your textbook multiple choice answer. So GF prime minus FG prime all over G squared. A third, this isn't really a new idea, it's just how do I know which one to use? So we use the product rule, we use the quotient rule. If it's in like that section, well then obviously use the product rule. If it's in the quotient rule section, you use the quotient rule. But how do I know which one to use? So let's look at just a couple of examples. We're not going to do them. I just want you to tell me if it's product rule or quotient rule or algebra. So if f of x is x plus 5 times x squared minus 7, what would you do first? Product rule, quotient rule, or algebra? Here's a hint. I would take 2 answers on this one. So you could FOIL it. That would be algebra. So if you FOILed it, then you avoid the product rule. And FOILing's not too hard. And if you FOIL it, then that leads to power rule, and power rule is really easy. So you can avoid the product rule sometimes. If you don't mind the product rule and you don't want to FOIL, then use the product rule. So sometimes you have options. F of x equals x squared plus 3x plus 7 all over x. X squared plus 3x plus 7 all over x. So what do you think you do there? Product rule, quotient rule, or algebra? Okay, you could definitely do quotient rule. You could also do algebra. Since you could divide x into each of those, that would get you x plus 3 plus 7x to the negative 1. And then you'd be doing power rule rather than quotient rule. So sometimes you can avoid the product or quotient rule. And on this one, the quotient rule is kind of a pain, so I'd probably pick algebra on this one. On the last one, I don't know. It kind of depends what your preference is. F of x equals sine of x over x cubed. What do you think? Product, quotient, or algebra? Jacob, product, quotient, or algebra?
Quotient.
Definitely quotient. There's no way to do any algebra on that. It's obviously not product, so it's quotient, period, amen. You have to use quotient rule on that one. F of x equals 3x squared plus 5x minus 7 times x plus 2. If we wanted the derivative of that one, Jake, what would you use? Product, quotient, or algebra first? You could use algebra. This is one where you could argue either one. So algebra, it's kind of a pain to it's not FOIL, to distribute all that. But then you have an easy derivative to take. If you do the product rule, well, product rule is a little bit more complicated, but you don't have to distribute everything. So you can pay me now or you can pay me later. Like if the cost is coming either way, that one's a personal preference thing. I don't know which one I'd probably do product rule because I'm familiar enough with it to use it. But if you're a little gun shy on it, or I guess you could do both. If you had extra time on the test and you wanted to check one, you could do both. That's not going to be many people though. All right, the assignment, page 125, 1 through 12 all. So that's very straightforward product and quotient rule. In fact, it just tells you which one to use. 13 through 29 odd. That's where some of those kind of coax you into using one or the other or using algebra. 30, 35 to 41. The rest of these are odd. 45 to 51, 63, 65, and 73. So 1 through 12 all, 13 to 29 odd, 30, 35 to 41, 45 to 51, 63, 65, 73. Sounds like a ton when you write it out like that. Let me remind you one more time that it's going to ask you to find where the horizontal tangent lines are. But what's that code speak for? Horizontal tangent line? What's that mean? Yeah, I got one of these. So what are you looking for if you're looking for horizontal tangent lines? Yeah, that's just a fancy way of saying where is the derivative equal to 0. So just gets you used to seeing a different kind of phrasing there. All right, so work those, and we'll go over them tomorrow, and I'll post some answers, video answers tomorrow of those.